Capnographic waveforms are normally displayed on a graph with the partial pressure of CO2 on the y-axis and time on the x-axis. A normal baseline on this graph is 0. The baseline occurs when the patient pauses between breaths or is inhaling, and it's indicative of a very low, nearly 0, partial pressure because it is the CO2 in the atmospheric air that is being sampled during these intervals. When the patient exhales, the sample now includes a much higher concentration of CO2, and the graph is deflected in the upward or positive direction. But let's back up a moment. The capnographic waveform is often broken into 4 phases numbered 0, 1, 2, and 3. Phase 1 is commonly called the inspiratory baseline or the respiratory baseline. There can be a little bit of confusion here if we lose sight of the fact that the graph is just showing us the partial pressure of CO2 in the sample. It does not directly tell us what the patient is doing because the CO2 will be 0, whether they're inhaling ambient air or just not moving any air at all. Most of the time, most people don't take a long pause between breaths, and phases 0 and 1 together are correlated with the action of inhaling. But if a person paused at the end of inhalation, this physical pause would also be hidden in phase 1. Phase 2. Phase 2 is called the expiratory upstroke, and it's important to understand that phase 2 is a transitional phase. During this interval, the air in the sampling chamber is transitioning from air that had been sitting in the anatomical dead space to alveolar gas. The anatomical dead spaces are mouth, pharynx, trachea, bronchi, etc. And although the air that had been sitting in these spaces had not participated in gas exchange, it did mix with some alveolar gas, and as a result has a higher partial pressure of CO2 than the atmospheric air. Moreover, the spaces closer to the alveoli will have mixed with more alveolar gas than those more distal, and this phenomenon accounts for the slope of phase 2. By the end of phase 2, the patient is exhaling alveolar gas, as evidenced by the relatively high partial pressure of CO2. Phase 3. Phase 3 is usually called the alveolar plateau. Sometimes it's called the expiratory plateau. This is a continuation of the exhalation that began in phase 2, but there's usually a sharp bend in the graph called the alpha angle that represents the moment when all of the dead space air has been exhaled and only alveolar gases are now being measured. Following the deflection at the alpha angle, the partial pressure of CO2 in the exhaled air is pretty constant. But it is normal to have a slight increase in concentration even in the so-called plateau, as the deeper alveolar gases are finally exhaled. The point of highest concentration marks the end of the exhalation and is the point at which the end tidal CO2 is measured. This point is known as the beta angle. It marks the transition from phase 3 to phase 0, and it also marks the transition from exhalation to inhalation. Phase 0. Phase 0 is called the inspiratory downstroke, and it represents the beginning of inhalation. It's usually of a very short duration because it doesn't take long for the CO2-laden air in the sampling chamber to be completely replaced by the atmospheric air that the patient is drawing in. It is normal for phase 0 to return the graph to a baseline of 0. In fact, this is a good time to highlight some of the characteristics of this graph that we associate with a normal capnograph. The baseline should return to 0, as we said. The rhythm should be regular. The alpha and beta angles should both be well defined. And the highest CO2 measurement, the end tidal CO2, should be between 35 and 45 millimeters of mercury.